Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Caines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann and today we're joined by Andy Rains. How you doing, Andy?
Hi, I'm very well, thank you.
Awesome. As the audience probably know is I've kind of got into serverless stuff quite a lot recently. And one thing actually that I noticed a couple of weeks ago, was a Symfony meetup video that came out. Sadly, I couldn't actually make the meetup, but it was very much in my headspace with serverless and adding in PHP there. And it was from your good self, Andy. So I really appreciate that. It was a really interesting watch.
Oh, well, I'm glad I'm glad to help, glad to get more people sort of interested in the space.
How did you actually get into serverless then? What drew you to it?
So I think it was probably maybe a year and a half ago now, which I suppose in the grand scheme of things is probably pretty early on in terms of the serverless movement. And it was something that came out of looking around AWS, really, just poking around, and came across this concept of being able to have serverless compute power, which was just, it blew my mind, really. And I was thinking of all the various possibilities and what I could do with it. And that just sort of got a little bit hooked on it and started playing around with everything I can, every opportunity I could. So that was kind of the start of it for me.
I'm definitely in that camp now. Anything you can serverless, you will serverless. It's an addictive thing. So people who don't really know and kind of haven't seen this space, then what actually is this serverless architecture or this serverless movement? Okay,
so I guess it's probably best described as being able to run sort of functions or software in the cloud where you're only paying for it on a very sort of small metered level. So there's a number of providers out there, but I'm going to keep referring back to AWS because that's the one I'm most familiar with. In that case, you get charged by the 100 milliseconds. So every 100 milliseconds that you're executing for, you get charged for. And then beyond that, you don't get charged at all. So you think about how computing can work for, say, a website or an API, which is where my background is in building a lot of APIs. It's very request-based, which means that you get a request in, you want to process that for a certain period of time, and then once you've produced the response and you've sent it, you're not really doing any work anymore. And so rather than having to have servers kicking around waiting for these requests to come in, which you're paying for the whole time, instead you're only paying for what you actually use. I think the other big advantage of serverless or function as a service really is around the idea that you can that it will scale on an event-driven process. So when a request comes in, that's when your function kicks off and does all your processing. But if 10,000 came in at the same time, then 10,000 would be spawned and all execute. And that means that really your scalability becomes almost infinite, really, which is just a really, really powerful thing when you start to think about it.
Absolutely. And it completely changes the way you think and perceive kind of designing these things. And you're kind of, what you feel is possible. Because like you said, provisioning servers, having always on servers and, it's the updates. It's all these things to do with having a server. It's, actually having to set the server up to then manage that load, expected load, having to assume, right, how much load am I going to get on a day-to-day basis? Oh, maybe Black Friday comes around and I'm going to have more load or something. Maybe there's going to be high traffic times. With this kind of, abstraction, you just don't really think about that. And you fundamentally just think of, a function as a service. It's very much kind of like a pure, you have to consider parallelism. You have to consider, it's itself that it could be working in parallel with other things and stuff. It's a really great way of thinking.
Yeah, absolutely. And I think actually it feels quite constrained at first, particularly if you're used to having a server which is always there, and you've got temporary space you can play with and all that kind of stuff. But I think those constraints are really powerful. They actually start to make you think more about your architecture. And for me, at least, has got me to the stage where even when I'm not working on serverless things, I'm still sort of working in that same mindset, which means I've got much more flexible and what I would consider better architecture out of it, which is really interesting as well.
And actually, one of the things that, from your talk, which I really enjoyed, was kind of at the beginning, you kind of gave a little bit of a history of how we got to serverless and through these spaces. And it is actually quite interesting to kind of see especially like kind of it's only been around 20 years of kind of development of how we've kind of changed the way we work. And from now we're at this very high level where we've got serverless. But before that, would it be all right if you maybe going through some of the history from like on-premise?
Yeah, so I think, like you said, about 20 years ago, I guess we were all in the same boat of having to actually get a physical server where we're looking after everything about it. You sort of get one of these things and throw it in a data center maybe, but you had to look after like your storage and networking. You had to look after the servers themselves. You had to look after the operating system, and if it needed patching, you had to keep on top of all that security. And then on top of that, you've got all the other things that you would normally have to look at, I guess, in modern cloud computing. You'd sort of take this for granted. But so then you get to your runtime. So you're looking at, well, I guess PHP or Node or whatever your runtime is. You've still got to be looking after scaling as well. Like you've got one piece of tin, one server sat in a room somewhere. What happens if that runs out of grunt? You need another piece of tin. And it was that was kind of the way we worked, I guess, about 15, 20 years ago. I guess from there, it would be about 10 years ago now, around 2007, I think, was when AWS really sort of cracked into the market, was when you started to get infrastructure as a service. And this is where the networking and the storage, all your hard drives and your servers even are all sort of taken away from you. You don't have to worry about them anymore. You let Amazon worry about that, and then you're still responsible for everything from the operating system up. So you still need to, keep on top of security patches and things like that, but you don't have to worry about the lower level sort of infrastructure, I suppose. You just get a virtual machine, and as far as you're concerned, it's a server which you can play with, and it's easy to spin them up, and it's easy to throw them away. So you start to get this, rather than you looking after a server and treating it as a pet, you can instead just treat them as cattle. You don't name them anymore. You don't really care. You can bring a new one in, you get rid of an old one. Like it doesn't matter too much for you. So that was I would say a huge shift for an awful lot of people, going from the idea that you were looking after absolutely everything to looking after, well, a smaller domain of that, I suppose. So that's so like your AWS, Google Cloud, Microsoft Azure. There's a good few of these.
They've all started now, haven't they? I think it all has spun up from the AWS, hasn't it? AWS EC2 really did kind of pioneer this movement. And like the whole idea of like economy of scale and things, because they're dealing with it at such a big scale, they can give you these savings and spinning up these boxes and stuff, which you would never, the compute power that you can just spin up for an hour, you would never even perceive that you could even, envision to actually be able to use, at the point where it was an on-premise, because you'd have to actually buy that stuff. And all the lead time for actually getting it, actually, setting it up, provisioning it and everything.
Yeah, absolutely. I mean, I've worked in industries which were still working on this basis for, one reason or another, where you say, well, we need some servers in time for your sort of your Black Friday or similar event, and say, well, okay, well, it's going to take us 6 months to get those servers in. So what do we need now? And, you have to get all those costs signed off. And it's a huge upfront capital cost for businesses as well. To actually buy these servers, and then give it a year or two, and you're going to need to replace them all because they're becoming obsolete. It's an incredibly different world to just being able to say, oh, you know what, I want some servers in the next 5 minutes, and you can just press a button and away you go.
It really empowers you, doesn't it? And the design and actually the business strategies that you can do because of the fact that you have this kind of underlining, infrastructure as a service. You're just not thinking about that.
Yeah, absolutely. And I suppose in the grand scheme of things, maybe you could run your own infrastructure slightly cheaper than you can buy it from AWS. But like you say, the economies of scale are such that you'd be having to run an extremely lean operation to be able to even match that. But then they give you all of these benefits as well, which you just simply can't get by doing it yourself.
That's it, exactly. And it seems like every revision that comes out, every new build, every new instance type, they're always increasing speed and performance, but then actually reducing cost, which is just the most crazy way of looking at it, where actually, you get better performance for cheaper.
Yeah, no, it is pretty incredible. And in fact, I've been bitten by this in some respects, where you can say to AWS, okay, well, I promise to buy a year's worth of, and you reserve the instance, so you get it for a cheaper amount. And then a month later, they say, oh, well, we've just updated all of our instances, and now it's these new instance types, which are more powerful and they cost you less. And you're like, but I'm sort of tied into the old one now.
Oh, no. So they have brought out that whole kind of, isn't it like that you can actually use some of those credits if it's on the same type, but then if it's a completely different type, then you are unfortunately at the mercy of it.
Yeah, there is some flexibility there. And it's just really, I think
for this exact reason.
where that, like with the hindsight, you can kind of see how you can structure that in a way which is going to be really good for you. But when you first start out, that's when you get burned and you sort of realize that you've just bumped some money in for something which isn't quite as good as you thought it was going to be at the time.
No, I feel that pain. I know exactly what you mean. And then, so from infrastructure, then we kind of go even a level up there, and you get like the Heroku's, the platforms as a service. Yeah. Would you mind explaining kind of like what the differences are there?
Yeah, so I think this is where you go from your infrastructure as a service to platform, is where the operating system and the runtime has been taken away from you. So in Heroku's case, and there are other providers out there, you just select and say, well, I want to run a Node app. And you don't have to care about what operating system it's running out and all the security patching. That's all done for you. You don't really need to care about the runtime. You just expect they're going to be keeping you fairly up to date so that you keep with the latest bug fixes and the latest security patches and so on. So at that stage, the things you're responsible for are your application, which you want to be responsible for, and your data. Again, those are the sort of two key things that your business really care about. And you're also responsible for the scaling still. So this is where platform as a service doesn't quite come to function as a service, is on the scaling factor. So this is what I was alluding to earlier with the whole event-driven architecture. So with platform as a service, you're scaling, you have to say, okay, well, I want one instance, and that's going to look after my request for a while. And maybe you can configure some automated things in there to say, I'll scale up to 2 if the load gets too high, or maybe 3 or 4. But fundamentally, you're having to sort of decide that for yourself. And with all the will in the world, they're not going to spin up, like if there's a huge spike, you're not going to spin up quickly enough to cope with that spike. They'll sort of come in after the spike's already been and gone. And we've certainly been burnt with that a number of times in the past as well. So that's really the last thing. Oh, and also that even if you've got no traffic, you're typically going to be running something in the background there, which you're still paying for.
That's it, yeah, because it's the whole kind of their abstractions of dynamos and things like that, where you're still considering compute as kind of a bucket of like how much stuff can you put into that bucket, and then you've got a couple of these buckets that you have to expand out on, as opposed to functions where everything's just an event and it is just scaling to infinity, as you mentioned.
Yes, yeah, absolutely. That's a really nice way of putting it.
So one thing is, like, you mentioned the cloud there, and cloud gets thrown around a lot. But in all of these cases, like, how has cloud computed helped pioneer this, serverless, but also kind of all of these things?
I suppose when you think about it, like what AWS have been, or at least what they say they've always been trying to do, is to give you as much as you can have and make everything as pay as you go as possible. And because they've got such a vast scale, they can kind of deal with the loads shifting around between all of their customers way better than you ever could. And as they grow bigger and they sort of finesse this whole pay-as-you-go model more and more, I guess really what they're doing is just taking their several million computers, I'm sure, and just allowing the ebbs and flows to sort of move around within their system, which doesn't really cost them anything to do. But it means that then they're driving some real value out to all their customers, and I think without that pooling of resource, that these kinds of things just couldn't really happen. So I suspect that's really kind of the driver that's come behind it, sort of evolution based on this pooling.
Yeah, it is fascinating, and like it is interesting. I think like AWS came about from the resources that Amazon did have back in the day with like Black Fridays and stuff, and that they thought, well, they might as well get some money out of it and allow other people to use it when they don't need to use it.
I think you're right. It's interesting because I think one of the first services they made public, if I remember rightly, was their queue service, the simple queue service, SQS, which is just like a really neat abstraction, which is very easy to use and it's fairly low cost. And just from there, they found that that's quite popular. And then we also manage all these servers, so why don't we give people virtualized instances and they can play with those? And it's crazy to think that a book retailer could have got from doing that to being like the world's biggest cloud computing service.
And like really profitable as well. Like, I mean, that's the thing, isn't it? Like, it is very profitable and very, like, I mean, every year their reinvents just remind me now of Apple launches, you know, the way that things are just released and stuff. It's just become a developer, you know, love fest.
Yeah. And I do find myself on that, you know, with my fanboy cap on a little bit as well, I must have.
Absolutely. It's hard not to. And then from there, actually, because it's very interesting, because when I looked at serverless, I always, you know, was thinking of, you know, the function as a service and things like that. And, you know, obviously you look into cloud offerings and cloud computing, and you've realized like the SQSs of the world and things like Cognito for authentication and Ortho and stuff like that. It's actually interesting that they're actually split up. And I didn't really kind of think of this, where you've got the back end as a service and then function as a service. And they're both kind of melded into this serverless world where you're just trying, you know, like the use of rich applications and stuff, rich client applications, SPAs and stuff. You're trying to get away from having to write code in the case of back end as a service, or you're stitching together a couple of like pre-made components from all these different third parties. And it's just this idea of like reduced development costs.
Yeah, I think this is something else which gets sort of quite confusing in this space, is what serverless actually means, because it seems to mean different things to different people. And I think for me personally, my definition has probably shifted even over the last few months. Certainly when I got into it and I was talking about serverless, I was always thinking of function as a service, you know, AWS Lambda. But over time, I guess I've come to realize that actually it's anything where you don't really have to think of the infrastructure. But I think there's another point that I would put in there, which is that if you're not using it, you shouldn't be paying for it. And for me, I think that's an important factor. So so a lot of these back-end as a service models, actually, some of them you are literally only paying if you use them, but others you will be paying some kind of service rate under the hood as well. So it's a little bit tricky to know exactly how to define these things. But yeah, I don't know. Have you got any sort of thoughts on that?
No, I think I really like your thinking there behind that. You know, it is the cost. I think, you know, what is one of the most influential things about this is the cost model. Like, how can you start to use this in a real life application is the fact that it's viable cost wise to do. So the reason why you're actually able to, you know, expand out and have this scalability is the fact that you only are paying for what you actually use. And it's very hard to perceive, again, with this always on kind of architectures that we had to provision servers. We have to think of contracts with like services and stuff, where AWS with the cloud computing they've done, you know, Cognito, you pay for only what you use out of it, the requests, CloudFront, cloud, you know, S3, I suppose you're paying there for like storage of objects and stuff, but you are only paying for like requests and things going in and out. It's what you use is what you have to pay. And it does completely change the way you can architect a system.
Yeah, absolutely. And the S3 one is an interesting one, because you say you're paying for storage. I think there's where I would kind of like allow my definition to drift slightly is whereas I probably would consider S3 as serverless, because you don't have to care about the scale, that just magically can do whatever you throw at it. And if you are using, say, 10 gigabytes and then you suddenly drop it to 5 gigabytes, you're only then paying for those 5. It's not like you're having to buy it in chunks like you would a hard disk or something like that. So there is still an element of that sort of pay as you go to it, even though obviously storage kind of has to hang around. So I guess you do have to pay for it.
Yeah, I suppose you could kind of conceive like, you know, storage is a use of like a function running constantly. So, you know, you could kind of conceive it as, you know, you are only scaling up and down as you want, but, you know, that storage has to stay there. But you are only paying for what you need. You're not having to reserve 10 gigabytes and only use 5. You are only having to pay for 5.
Yeah.
And then obviously, you know, function as a service comes about, and designing for function as a service. How has it changed? You mentioned that it has changed the way you kind of think in general, but like, how have you actually been able to incorporate this into, you know, personal projects and actually, you know, into production?
So I think the big thing to think about it, and with building APIs a lot, I have been sort of aware of the whole 12-factor app thing for a little while, and been trying to bring any projects that I've been working on sort of closer to that 12-factor ideal, which actually, once you start to do that and you're thinking, you know, everything is stateless and you can't have anything which lives outside the lifetime of the request, as far as that sort of compute power is concerned, at least, you know, you can shift that off onto another service to do your data storage, either, you know, S3 or a database or something. Once you start to think about it like that, and you realize your application is essentially kind of ephemeral, is once you've got to that stage, that's really, really powerful. And then when you're building new applications, even if they are like your standard sort of always on monolith or whatever, as long as you're still actually following those rules, you get a lot of benefits. For example, like logging, rather than logging to a local disk on that server, which you then need to start monitoring for how full the disk gets and how do you ship your logs away and how do you look after all that stuff. If you just say, well, from the start, I'm not going to log to this server, logging is another problem. It's another sort of component. So all my logs will just flow directly out to that component. You've sort of gained that flexibility of architecture, and you've just removed a load of responsibilities you need to care about. And so, yeah, it's those are the kinds of things that I think have kind of come out of me playing around with Lambda in particular.
I do find it interesting because I'm very much interested in functional programming stuff and been for quite some time. And the idea of immutability just seems to kind of the magnifying glass, you can kind of really kind of put the lens on a lot of different things, where you're looking at code, immutable code is a lot easier to reason about. And then actually when you go up to the server level, and it's even kind of now looking into provisioning boxes and stuff and looking at immutable servers and like immutable applications, like the whole concept of just immutability really makes things simpler. And, you mentioned there with logging, you're trying to make the actual application code, the server code immutable, and the side effects are happening somewhere else where you don't have to deal with it and you can scale as and when because of the fact the immutability is there.
Yes, yeah, absolutely. That is really you put it a lot better than I did. That's a really important point of this whole thing.
It's just it is so interesting that immutability is just, especially as developers, we've been very much kind of in this side effecty world where we're constantly changing references and stuff. And even just looking at a server and the fact of logs is a side effect where, oh, great, now in logs, I've got to deal with this. It's not immutable server. It's more of a Snowflake now, maybe, or it's more of a Phoenix server where things can change a little bit. If you just consider things as immutable snapshots, and that's one thing, the infrastructure as a service gives you and containers and things like that, where you can just go back to a state. And if you only you very much restrict yourself that you can't do things like, we'll mention in a minute, like with function as a service, like the statelessness of it. But if you really take that, and take that and embrace that, your development and your architecture doesn't get halted. I don't think it impedes your development. I think it increases it and it changes the way you think about it for the better.
Yeah. And I actually, this is one of these things like constraints. A lot of people feel constrained by them, I suppose. But the constraints can be extremely valuable if they're the right ones. And I think it means you become a lot more, it means you think differently. It forces you to think differently. And when you start to think a little bit differently, you come up with some really interesting solutions. And then you start to see how powerful those can be. And immutability as a concept has obviously been around for a long time. And it's interesting. I suspect this is probably sort of a cycles in popularity with various different reasons over time. But it's a really, really powerful idea. And those constraints, which initially feel like it's making it not as useful, actually in the longer term can really promote good practices.
Everyone's been burnt by a reference problem in a bit of code, and everyone's been burnt by a Snowflake server where don't touch that server. It's we don't know how it got to this state, but it's magically going to stay there and it's going to work as it should.
Yeah, been there. More time.
This is it, and that's on the on-premise stuff where you never really the fact that you can tear up and down infrastructure as and when you want in like these. You mentioned the cattle and the pet thing. If you have a pet, you're nurturing it. You slowly get to this state with an application where you've changed the configuration files and you've kind of upgraded this, and you had to, while you upgraded that, change this little bit here, but you don't document that. The thing about Phoenix servers obviously makes it better where you start tearing it down and you're able to build up with things like Puppet and things. But to get to immutable servers where you essentially are just snapshotting, this is deploy, release it, done. It's just it's a great way of thinking.
Yeah, it is. I think the interesting thing about containers and that whole or snapshots in general, just that immutability, is that somehow you've got to be able to build those in the first place. And I think there's a real danger that a lot of people end up having sort of snowflakes which they become snapshots, which is sort of okay, but it doesn't really fundamentally solve the problem of if you somehow lost that sort of snowflake which you're taking snapshots from, you have no idea how to rebuild it. And so there is an element of me which is thinking, actually things like Puppet and Chef to build Docker containers, maybe that's a good idea because at least you can programmatically rebuild them then.
That's it. Yeah, you can then do the Phoenix model of it. And I agree with you there. I think people may try and skip out the definition phase and be like, well, it's easier for me just to snapshot this snowflake and I can go around it. But you're right. You haven't got a clear, concise definition of what that actual service, that application entails. It's, not been codified. You've just manually done these things on it. So it's not, in my mind, an immutable server in the right sense.
Yes. Yeah, completely.
And then, moving back onto function as a service, that we mentioned their constraints, and there are actually a lot of constraints with function as a service. Would it be, all right, to maybe go into some of these? You mentioned it's a very much an event-driven model and it's stateless. What other things are there?
I have a funny feeling, and I can't quite remember now, that AWS might have very recently changed this at reInvent. But another one from Lambda is a 5-minute execution time limit. So you can't just have these things running for hours and hours and hours. They get event driven, which starts them up, and then they're going to last for a certain amount of time. And if you hit that limit, then they just get killed off, and there's nothing you can do about it. And whilst that might seem quite, again, constraining, it doesn't. I don't think it is. It just means that you have to think about your architecture in a slightly.
You have to break up that service, break up that responsibility, because should something have to run for 5 minutes, is it right to be running for 5 minutes? And if it is, maybe you do then have to move it onto its own dedicated systems. Yeah,
absolutely. And there are going to be problems which can't be solved within an event-driven way, or not very elegantly anyway. So it's definitely not right for everything, but that is something which, as long as you sort of think about it and make sure that you really do need it to last forever, then fine, I'm okay with that. But usually you can find a way of it actually just sort of pinging up to do a little bit of processing and then going away, and then another event can start it up to pick up from where it left off, and that kind of thing. So I think that's one of the other big ones.
That's it, because with it being stateless, with the fact that you can't inferior containers, you can't just put a bit of the state on the server and then be like, I'll pick that up later on. You have to really consider third parties, again with the logging, where it's like, I'm not going to log onto this server, I'm going to log somewhere else. And it's the same with, I'm not going to store on this in this container, in this service, this function, I'm going to store it somewhere else. And it's breaking up maybe that execution of 5 minutes. Okay, maybe you need to have something that runs 10 minutes or has to do a lot of different things. Or break it up into its individual responsibilities and use things like SQS and these other means of being able to get the events and compose them together. It helps your design.
Yeah, and I think it really just reflects what has been good programming practice for a long time, which is, if you're doing object-oriented programming, certainly you don't want to be really using inheritance to get behavior. Composition is an awful lot more powerful. And you're just relying on components and splitting it into single responsibilities and all that kind of thing. And that's really what you're doing, but more at an infrastructure level. You're using different components rather than it all being sat within your same code base. You're just sort of spreading these things and connecting them together to make a more powerful whole, where each individual thing is really easy to reason about and really easy to understand. And then you can build these really complex systems which do the right thing.
Dare I say microservices? Dun, dun, dun.
Yeah.
Bringing in that word. Let's bring in that buzzword. We've got serverless in there. We've got to bring microservices in there.
I think it's whether you would take function of a service and call it a microservice, or whether they're nano services. I've heard people kicking that idea around. I think that's another very broad.
You'll probably get a suite of function as a service, like kind of a composition of a couple, maybe.
Yeah,
where you've got a bundle of them.
I think that's the way I've been talking about it when I'm talking to other people and describing some of the things I've built. That tends to be the thing. It'll be like 4 or 5 of these things, which are all trying to do a common, service thing, but each of them individually are running separately. So yeah.
One of the typical things, you mentioned APIs there actually, and that is interesting, is, people will want to use these things for, you say, events. And I think one thing around, I've realized with Lambda and with function as a service and all these providers is a good provider provides a lot of event input, a lot of event triggers and a lot of event outputs, side effects that you can do. It's kind of pointless having a function as a service if you can't actually interact with it that well. And that's one thing that AWS has done. And I, again, bringing up AWS, it's the one I'm as familiar with as well, where you've got like S3 bindings and things like that. All these different things it can do. It can do things on Cognito. It can do things based on Dynamo. It can do things based on API gateways, and HTTP is obviously a main one. Kind of what is then API gateway, like that concept of HTTP?
Yeah. Okay. So I think it's really important to bear in mind that these function as a services are they take some input and return some output. They don't really know the wider context from what they are. They really are just a function. So they don't understand, or they shouldn't understand, HTTP. So API gateway is really a way of taking HTTP requests, doing some routing on there to route it to the correct function. And then passing on the information to that function to be executed. It'll retrieve the response from the function and then sort of convert that back into an HTTP compatible language, which it can then respond with. And it can deal with the connections, and it can deal with talking HTTP to clients.
And it means also, these functions then can scale, like certain routes in your HTTP requests may get more traffic than others, and you can then expand and contract in that way as well.
Yeah, absolutely. So like I mentioned at the start, you get 10,000 requests all going into your, user login, which is all going to be the same function. It kind of doesn't matter. API gateway is going to handle that traffic for you, because that also has this sort of infinite scalability property to it. Pass it all through to the same function, which will presumably fire up 10,000 of these instances all at the same time. They run, they do their business, and then they shut down and they've gone away. It just allows you to build APIs or even websites, I suppose, without having to kind of deal with the HTTP end of things.
Yeah, and actually, there's one thing, probably the last week or so, more I've been exploring kind of API gateway. Quite a few kind of projects that are going about where they're able to kind of encapsulate maybe an Express application or something in the Node.js world, or, kind of like your general framework, like say like a Symfony 2 or, Symfony application and stuff, and really kind of just put that in a serverless context. And I'm just wondering, is that in the right vein of a function as a service? Would it be breaking up that into different micro kind of services maybe, as opposed to kind of bringing in your whole application and just plonking it into one function as a service with an API gateway route of a wildcard catch-all?
Yeah, I think this is one of those things which my first instinct was like, brilliant, let's get this monolith and just
that was me as well.
Straight into Lambda, jobs are good. And I think that is somewhat of an abuse of the of the architecture and the capability there. I'm not saying it's not possible to do, and in some cases, you have this thing, you're not going to break it up in just stop all development on it and break it up and re-architect it just for the sake of getting it running on Lambda. I mean, maybe you will, but it seems like a possible.
It'd be better to refactor over time.
Yeah, exactly. So really, if you can get sort of 50% of the benefit by this hack, I suppose, then why not? And with API Gateway, you can, as you say, instead of it doing all the routing and routing to appropriate functions, you can just say, you know what, just route everything through to this function, and the function will take over and deal with the routing itself, which is entirely possible to do. Like I say, I think it's sort of not quite in the spirit of the whole thing.
I think, but it's interesting because it's for me, it was the exact same, where I'm like, brilliant, I could just chuck this in now, and it's just we're running for what we get, we're running for what we actually use. But you're right, it's not in the vein of what a function as a service is. And I've seen a couple of these kind of encapsulations that encapsulate Express, and they say you don't have to worry about serverless, and it's like, well, actually, you want to embrace this model. If you're kind of not embracing it, but I can understand, if you want to bring things over and slowly refactor stuff, then it's great that you can actually do this, being able to actually go there, because changing it from the off just isn't a possibility for a lot of applications. And the fact to be able to reuse components and stuff and reuse the languages that you're used to, and it is just code, and testing, you can still unit test, you can still do testing that way. I think when it gets to integration test, it can get a little bit more fiddly, but being able to actually do it both ways and kind of slowly move over to what function as a service really means, it is a great thing. Yeah. And that's it. It's that once you, by having your sort of Express running on Lambda or whatever, you're not exposed to those same constraints. And like I was saying, those constraints are what change your mindset and what make you realize how you can actually build things in a really, really cool way. In a scalable way, because I'm guessing you can't really still scale in this way, because you're considering things with state maybe internally within it, requests and stuff, and sharing it between.
Yeah, and there's the danger as well that by chucking, I mean, I've not played with the Express one, but by chucking any old framework at it, it might be that those frameworks are expecting to be able to write to temporary storage, and expect that to last more than one request and all these kinds of things. A lot of assumptions have been made in a lot of these frameworks because of how prevalent monolithic structures and even microservices, which are always on, have been for such a long time. And so it's not really the fault of the frameworks, but those assumptions are sort of baked in, and you might end up getting bitten by a few of them if you're not too careful.
Yeah, it's just a completely different paradigm. And it is interesting, because you mentioned that the 12-factor app and the fact of statelessness there. But one thing you can kind of slowly, you can kind of go like having this kind of baked in even caching, or maybe like caches that are generated because of requests that have occurred in the past and stuff. You can kind of be like, oh yeah, it's fine to have a little bit of a cache. But obviously in the case of function as a service, I mean, it's truthful that you really cannot expect that this, there's going to be a hot cache. You're going to have to generate everything, and you are going to have to bring the cache with you if you want to actually run that. Yeah,
absolutely. And I think there's when it comes to a lot of caching, what it really means is don't store it to your local disk anymore. You need to push it off onto Memcache or Redis or even to a data store of some description. That's what you're sort of forced to do. To make this work nicely, or if it's code, like you say, like Symfony is a good example where on first run it'll build like a big set of cached PHP files so that its performance is better afterwards. Now those you have to bake into the function, into the Lambda. So what that means is you need to be on your local machine, build that cache, and get all the files onto your file system, and then you zip them up and send it off to be run in Lambda so that they're ready and don't need to be changed.
And I'm sure it's not environment specific if it's on a Mac or Windows or something, and you need to make sure it targets Linux or the Amazon AMI.
Yeah, absolutely.
Because actually that's one thing, mentioning like function as service. So like underlining kind of like, how do the platforms typically host this? I think it's always interesting to kind of understand even just a high level of kind of how they're getting away with this, because it does feel a little bit like magic that they can just run this thing and scale it out as much as they want.
Yeah. No, it is magic.
It's all magic.
No, so I mean, this is my understanding, and maybe I'll get some angry emails or something. But yeah, I think under the hood, really, they're just using something similar to Docker, containers, certainly, where your code is sort of sent up, it gets turned into a container, and then as requests come in, you can spin these up quickly, let them execute. And actually, in AWS's case, they don't die off straight away. So this is, whilst you always need to think of them as being like they're killed off after every request, in reality, they do hang around for a little while. And that's kind of to improve the next request performance, if you like. So your first time, you're going to pay a bigger penalty for starting this thing up because you've got to get the whole container going. And then if it just sort of hangs around on the off chance that there's going to be another request, next time it can just execute straight away. So what you find is that, I should say, you're not paying for that. That's all sort of handled for you. You don't have any control over it. But what you do find is that you get these, what everyone refers to as cold starts, which is where there's nothing there and the Docker or container has to get started. And then after that, you are on warm starts where there's something already ready for you. And if you think about the way what that really means is that if you have one request per second coming in, and that's keeping one sort of container busy, then if you suddenly get another request in, it's not like that first container can cope with it anymore because it's already busy. So that means you get another cold start when the second request comes in to deal with it. So that's kind of how it's behaving, at least.
Obviously the cold starts, and I suppose, in that case, it's the application and the actual infrastructure and languages that you're using. Like booting up the JVM every time definitely will impede more of a cost than maybe a smaller scripting language like a Node.js application.
Yeah. And when you look around at, I guess we'll come on to this, but the various sort of shims that people have built, they tend to be based on either Python or Node because their sort of startup execution times are so much quicker than the JVM or sort of a C# environment.
Because you get I know that moving on, we're looking at serverless framework and there's a lot of plugins to do with serverless warm-ups and things. And they're kind of little hacks where it is really an implementation detail, isn't it? That it's going to be around for a little longer than you expect. So what you're going to do is you're going to be like, I know that if I just keep calling this action every so often, I'm just going to keep it keep it hot, you know, in the implementation detail. Like, you shouldn't really be expecting the fact that it should be there, but it's just a performance boost because of the fact that, you know, under the hood it's actually doing that.
Yeah, and this was really, I think early on with Lambda, this was something that everyone started doing. They'd set up a CloudWatch event, which would fire every 5 minutes or every 2 minutes or something, just to sort of ping your Lambda and keep it warm.
How much do you think Amazon hates that? I'm just thinking kind of like, you know, the fact that you're just pinging it just for the fact that you want to keep it warm to ensure that maybe some traffic will come.
Well,
but
I don't know. I don't think I don't see why they would care. At the end of the day, you're paying for the CloudWatch event and you're paying for the execution time. So it might as well be another request as far as they're concerned.
Yeah, I suppose. Yeah. And I suppose it's just, you know, the fact that they're then having to keep it round, and you're really kind of like, they only keep it around for 10 minutes just in case, but then you're taking advantage of that 10 minutes or 5 minutes, and you're just kind of consistently just keeping it going.
Yeah. So like I say, this was something which used to be much more of a problem, and then I guess maybe it was about a year ago now they made some improvements so that the whole cold start penalty was nowhere near as high as it used to be. So it's less necessary to do that kind of thing now. But if performance is really, really key, then maybe you still want to do it. But I think this is just another one of those constraints which, you know, you should be trying to find a way of making that latency not as important. Like, I know that's not going to fit for every purpose, but for a lot of things, you know, costing another few milliseconds here or there is not really the end of the world. And overall, it just means the whole thing's a bit simpler.
No, absolutely. Again, it's a design consideration and constraint that you kind of have to work around.
Yeah.
And then, you know, mentioning kind of with the function as service and all these things, you know, you're kind of vendor specific, and you have this whole scary thing of kind of concept of vendor lock-in. You only rely on the fact that you're using AWS or you're using, you know, other platforms that are function as a service. There's frameworks out there now like Serverless framework, which try and abstract away some of this, you know, where it allows you to kind of write in a higher abstraction where it can then compile down and do its own things to do like the, you know, the CloudFormation scripts or set up Azure for you and things like that. I'm just wondering kind of like, what's your experience with using Serverless framework?
Yeah, so Serverless framework, and there are other projects, but this one seems to be the most popular.
It's got the name Serverless, so it's serverless.com. It really has kind of one out there.
Yeah. I can't remember what it is. I think it was called Jaws originally because it was a JavaScript only, like JavaScript on AWS. But yeah, they changed the name when they sort of expanded it out to different languages and then realized they could support different cloud providers as well, which I suppose is the point of your question. But I think what they recommend is, and really this is a good practice anyway, is that your code should be provider agnostic, as in you just don't care how you're getting executed, with the exception of the very sort of first bit, the entry point, which is going to look different for each provider. So when your method gets called, it's going to have a certain signature which you'll have to abide by because that's just the way it works. So if you keep that really, really thin, so the first thing it does is just call off to the rest of your code, and then it returns whatever the rest of the code returns, then, or maybe with a bit of transformation, that will keep you fairly provider sort of free, so you don't get too locked in. There's obviously going to be a little bit of work to move from one to the other, but that's the case with pretty much everything. But yeah, as long as you do that, you're okay. The other thing is that serverless framework isn't just about deploying your piece of code. It's about setting up everything around that. So like looking after which events trigger it and which services are going to exist and which buckets in S3 are going to be around and all this kind of thing. And for the vast majority of tasks, it's really good at abstracting that because you can just describe it in YAML and then it goes and deals with that for you on the service provider for you, creating all this thing and linking it all together. For more complex or more provider specific things where, you know, the serverless framework doesn't have the ability to do this built in, you're going to have to start to reach for a bit of CloudFormation or similar to kind of help tie things together, which is a bit of a downside. I suspect over time that's going to kind of ebb away. The serverless framework moves at a frightening pace, and it's just incredible how much stuff the community is adding in and around that. So yeah, it's one of those things which I think over time is going to become less and less problematic. But ultimately, each cloud provider does offer slightly different services, and you know, if you need some kind of big data compute from Google, or you want some elastic transcoding from Amazon or something like that, you know, they are specific things which only those providers give you. So there's always going to be a little bit of make your bed and sleep in it, but
I think that's what we've recently moved actually from like kind of having servers on-premise stuff really kind of, where we did have a little bit of AWS and a little bit of kind of virtualization, but moving and kind of, making our bed in AWS. And you really have to kind of weigh out the pros and cons. And it's like, would you prefer to take advantage of, are you going to get more benefits out of using their services and taking advantage of their services than trying to be agnostic and away from them? Vendor lock-in is always that scary thing that everyone kind of screams about, but you do sometimes have to have give and take on certain bits. And you're right, saying, like having this very small level, your delivery has a very thin layer that is able to just translate between that is great. Just as a good design principle, just having your packages that are agnostic of anything really, that are clean code, that you can do unit tests and everything and don't require all these, external third-party dependencies. It's just very good architectural patterns anyway. But having the vendor lock-in with, saying that you're using S3s and you're relying on the fact of that, I think you just kind of sometimes have to embrace that a little bit, which is horrible to think, but you just kind of do have to. If you want to take advantage of it and reap the rewards, you really have to kind of just embrace that.
Yeah, absolutely. And there is there's a cost to everything. There's a cost to staying agnostic, and there's a cost to vendor lock-in. I'm sure was it PaaS? Which sort of suddenly decided they were turning off all their services.
Yes. But they released it, didn't they? So you can host your own.
Yeah, it's not really it's
not the same type of thing now. It's kind of, hang on, I'm now owning your code.
Yeah, exactly. It's like, I went from this thing which was really handy because I didn't have to do anything to, now I have to actually look after it and I have no power to sort it out. Like, yeah, I think that's a really great example of when vendor lock-in looks very, very scary. And I can see why people get, quite het up about it. But it's I suppose at the end of the day, like, if PaaS hadn't been around doing what it was doing, those apps that were reliant on it wouldn't have got off the ground because there was no other way to do it. So they could have spent loads and loads of their time developing the same back-end services and everyone's reinventing the wheel. Or you can concentrate on the thing that's giving you business value today, and giving your users that value as well. Like, ultimately, you're building things to give to users of some description, and make them happy. So the quicker you can do that and the quicker you can deliver value to them, the better. And if that means you are taking a bit of risk when it comes to vendor lock-in, then I think that's a risk which you need to evaluate, but is generally worth taking. As long as you've got a sort of, maybe in the back of your mind a get out of jail card. What happens if tomorrow AWS sort of goes, oh well, we've got 6 months before all our services turn off. Like, what are you going to do? Those kind of things. Whilst it seems incredibly unlikely, nobody saw PaaS going under either. So it is a possibility that needs to be at least in the back of your mind.
Yeah, it's true. And I think what's annoying though, and what kind of is one of the catch-22s is that the vendor lock-in is actually one of the pros because of the fact you get to reap the rewards of what they are doing. Whereas, you say like, oh, can I transfer this over to another provider? Well, they don't provide that. Like you're using the things that have its strengths, like Dynamo and things like that. You're taking advantage of what that provides. And if everyone provided that, have any standards, it would take years for them all to reach consensus of what's right. So you kind of do have to tie yourself into things to be able to get and take advantage of it.
Yeah, absolutely. And it's only the same as, picking a database or something. There are so many.
How many RMs have we've seen that have tried and failed? So sometimes you just have to own it.
Yeah, exactly. And it's even things like, DynamoDB came around actually a surprisingly long time ago. And I don't know if I'd say they sort of started the NoSQL trend, but they were certainly in there, near the start. And now look at how many different solutions there are out there, how many different databases, which all have their pros and cons. And it is like everything in life, try and pick the right tool for the job. Much they hate that phrase, but it is something.
It's very applicable here, though.
Yeah, try and consider.
And actually picking the right tool for the job is, using our good friend PHP. You came on my radar actually because of the Serverless PHP project that you released on GitHub. And I'm just wondering kind of like what does it encompass and what drew you to make it?
So, like I said, I've been sort of following Lambda and things for a long time, but my day job is PHP pretty much through and through. I mean, we dabble with other things, but it's very, very much PHP. And the big blocker was that AWS Lambda doesn't have native support for PHP, which made me, that was difficult. It made a sad Andy. So I've been looking around and evaluating various different languages because we really had some good use cases for using Lambdas. And by playing with all the different languages, I then came across some shims, really, some things that people have made. So like Go is also not supported natively, but someone has managed to make a little shim which kind of bootstraps through Python and then gives you what feels like a native environment to do Go programming in on Lambda. And there was another chap, Zero Sharp, who had kind of done a bit of a proof of concept of, oh, maybe we could do the same for PHP. Now his proof of concept was sort of fairly basic, and but it did prove the point that you could run a PHP executable and the language on a Lambda. So then that got me like really excited and thinking, okay, now I can use the language I'm most familiar with, and more importantly, all the tooling and components and the community that I'm used to, and are actually really good, and take that and use this new technology as well. I think this is something which, this slight aside, lots of people, whenever you say, "Oh, I'm a PHP developer," you see their eyes kind of like twitch a little bit, and you get the sort of slightly
PHP, you're still around.
And all of a sudden you sort of have this feeling like maybe they're looking down on you a little bit. But I think that's probably just it has I guess it still has a little bit of a bad reputation. But I think that's from years and years ago, and no one has really sort of looked at it so much recently. It's just cool for it to be uncool. But the fact of the matter is, it's a pretty quick language. It's got, I think the tooling is the biggest thing for me, and the community strength around it all. Symfony and all the things sort of built on its components are fantastic, and things like PHP spec, BHAT for all testing is they're just so good. So I wanted all that, and I wanted it on serverless. So this was a Christmas project last year, actually. Seems oddly the only time I actually really seem to have to muck about with things. I took what Zero Sharp had done and took the principles of it, and then tried to enhance it so that it would feel very much like it was a native execution, the same way as Java or Node or Python is on Lambda, because with the intention being that when AWS hopefully finally support it natively, your code will just sort of slot in, and it won't really need any major changes. So that was the broad thinking behind it.
No vendor lock-in from you. I like it.
Yeah. So in terms of, I guess, how it works, if you're interested.
Yeah, I mean, that's one of the things, because I think for me, like I've been playing around with a little bit of Lambda, and then I realized through actually your thing, I was like, hang on a minute, he's running PHP. It means you can run, native compiled code. And I started playing around with things like socks and stuff to mess around with audio. So yeah, how did you get around to actually compiling PHP then for Lambda?
Yeah, so the way this works is I'm using Node as a shim or as a bootstrap. I sort of mentioned that term a few times. What that really means is when it gets executed, it's actually executing some JavaScript first, and then that JavaScript executes a PHP executor.
So Lambda thinks it's a Node.js app that you're just doing whatever in.
Yeah, exactly. And when I am executing the PHP binary, I give it the same environment variables that Node had when it started, so all that stuff sort of passes through. And I'm also using sort of Unix file descriptors to be able to pass the right information back and forth. So using like standard out, I just decided to use as the return thing. So when PHP does like a print or an echo or something, that goes back to the JavaScript, and it interprets that as a response and then sends that back, sort of JSON encodes it, and it all gets sent back. I use standard error for the log line. So every time I use sort of a standard monologue setup in this particular shim in PHP, that just streams everything to standard error, which the Node process picks up and then can stream it into the native logging, which will go to CloudWatch logs. And finally, the last thing is on AWS, you're provided with this context object, which gives you a load of static information about the context in which you are executing. So that will be things like how much memory you've got to play with and things like that. But it also has a method on there which you can call to find out how long you've got left before your execution time is up. And I was thinking about this. It's like, how am I going to get that to work in PHP?
Yeah.
Like, it needs to
bi-directional communication. How are you going to do that?
Go back and forth. So I opened a third file descriptor, and all that really does is it just sends a character on it. The PHP sends a character on that file descriptor over to Node. Node notices that there's a character there, executes the native method, gets the response from that, and then sends it back over that pipe. So actually, it's not that complicated the way it's really working. But what it does mean is that once you're in PHP, it does feel like you're actually executing the native function. So that's what it's doing. I think the other part is that you've got to get the PHP binary in there somehow.
That's it, yeah.
And so you're running, I mean, I have a Mac, so I'm running on OS X all day, or macOS now, and other people are going to be running Windows or whatever. In Lambda, what they're running is Amazon Linux. So it's their particular flavor of Linux. So your PHP binary that works on your Mac is not going to work on Amazon Linux. So what we had to do to get around that is actually use Docker to sort of take an Amazon Linux Docker image, then build PHP inside that image and get the binary back out. And then you can kind of package it up with a binary which won't work on your local system, but obviously will work in Lambda. And so that gets pushed out as well as all your code. So that's kind of the way it all sits together.
Really cool. And I really like kind of your API around it and there's the decisions made there, because it does seem like quite a hard task actually to kind of get around it, and quite an interesting task.
Yeah, so I think with in terms of the communication between the two, that was I guess I just made some decisions and it seemed to work, so that was great, and I was quite pleased with that. In terms of making it feel native, I went and took the Java. I took as much from the Java native documentation as I sort of felt was necessary to try and make it feel as close to that as possible, because in my mind, the PHP looks probably most similar to Java out of the languages it supports. So that's kind of the way I went, with a few exceptions here and there, which are more like the JavaScript one, because we don't need the same strict typing. But that was sort of broadly the approach that I took.
So what drew you then to use Node.js then, other than like maybe Python?
There wasn't really I wish I could say there was a good reason. There wasn't.
Everyone likes JavaScript. I'll understand that.
Yeah, I mean, JavaScript's one of those things, particularly on Node, which, because of the asynchronicity of it, I just always get a little bit like bogged down. It takes me a little while to get my mind in the right place again after I've been doing PHP all day, just to try and like get what's going on. And that gear shift is quite difficult. So why I use that rather than Python, I don't really know. It seemed to be the sort of, I could see how to do it quite easily, even though I'll be the first to admit my JavaScript skills are not like exceptional, but I could kind of see how to do it fairly easily. So that was where I started from. I think in retrospect, maybe Python actually would have been a better choice. From reading around, it seems like Python actually boots slightly quicker than Node does, but again, we're probably talking about a matter of a handful of milliseconds.
I think that's it, isn't it? Because I was going to mention that, like maybe playing around with Python, you would get some benefits there. But like you say, like because that one thing actually from your talk, which was really good, was you went in depth into like how performance of it and how it actually kind of relates. I'm just wondering, maybe you could speak about a little bit about the performance. So
that's a particularly interesting point, and I think the difficulty here is that PHP, you're actually having to start the binary. Ultimately, on every request, it has to get booted and go. And what that means is that it's going to take a fair bit of CPU time and a fair bit of memory to get going. And that, unfortunately, has quite an overhead. So if you're running on the smallest lambdas, which are like 128 megs of memory, and then that's proportional to the amount of CPU you get, so that's like the least CPU lambda you have, then I was seeing some overheads like for just doing a simple hello world on PHP versus a simple hello world on native Node. That was actually being like maybe getting on for 200 milliseconds of overhead just to do that, which is no good when Node can execute it in like 20 milliseconds. That's a huge cost that you're paying. But the good news is, as you go up in memory and therefore also in CPU, that cost comes down. So once I got to about the gigabyte mark in terms of memory, that's where it seemed to sort of flatten out, and then you're starting to pay maybe 30 to 40 milliseconds boot time. I should say this is all with PHP 7.1 that I was dealing with it. I understand 7.2 actually has some performance improvements in it, so it might be that this actually gets a little bit better. Your mileage may vary, as they say.
No, it's really interesting. And, it is also that thing of like, Yes, at a benchmark level, maybe it's not as performant, but maybe for the fact of the tooling and actually the development, and you can actually bring some of the services and libraries that you already have brought in, and you want to take advantage of the serverless and the function as a service paradigm. The benefits outweigh the cons there. And not moving to another language and having to understand another language and kind of learn a lot of stuff.
Yeah, and the vast majority of problems and applications are not ultra performance critical. Otherwise, we'd all still be writing like binary or assembly or something.
That's it.
there's a big cost to writing that in terms of man time. And you don't want to have to deal with that. It's much better to be in a place where you can be really efficient as a worker, and because that's how you're going to deliver that value out as quickly as possible to your users. And if you are in a performance critical Lambda, then PHP is probably not the right choice, not at the moment at least. But the majority of the time, you can cope with a few more tens of milliseconds.
And you just design it in that way. And actually, one thing with it is like, do you envision that AWS will in the future support PHP like Azure does? And I don't know if like OpenWhisk maybe does.
Yeah, I'm pretty sure OpenWhisk has some support for it. I can't speak for Azure, but yeah, I would really hope that they will support PHP in the future.
I suppose for them it's the maintenance of it, isn't it? That's the hard part. I mean, they already support 2 versions of Python and Node, and then they support Java, which then supports all the JVM languages, and then C#, which then supports all of the CLR languages.
Yeah, and I can understand that. But then at the same time, like, the whole point of a Lambda is that it starts up when the request starts, it does some processing, and it dies off, which sounds an awful lot like a PHP lifecycle to me.
That's exactly. Doesn't it make you scream when you think this is exactly what PHP was made for, was, this very short HTTP request kind of lifecycle?
Yeah. And so with that in mind, I think the biggest challenges they're probably going to have is that with PHP, there's still a lot of C extensions which are sort of compiled into the binary if you need them. And I'm not sure exactly how they go about supporting everything that everybody wants. But if they can make that work in an efficient way and just make sure that it sort of broadly supports the important extensions, then maybe that is the sort of the way they'll end up getting it out there. Ultimately, like, you always hear these stats about how much of the internet is powered by PHP. Now, I know most of that's going to be like WordPress blogs and other nonsense like that, which probably...
And Facebook.
Well, Facebook's a great example, yeah. Although I suppose it's Hack now, isn't it, rather than PHP. But yeah, like, you hear all those stats. There's a lot of PHP developers kicking around. And I think it would be a little amiss of AWS to sort of overlook them, to be honest.
And then with that, then, like, what kind of, firstly, actually, have you actually used this in production? Have you found, because was this a use case, obviously a Christmas project, then did you actually bring this into the workplace and actually get something shipped out using this? Yeah,
absolutely. We've got, it's been running for, I guess, about 9 months now in production, with an earlier version of my project that's on GitHub and is open source. It's kind of moved along a little bit since then, but we've not really had too much need to change this service that's been running. So it's been sat there sort of dutifully doing its job for a long time. And
brilliant.
Yeah, it's fantastic. And again, this was something where the raw performance didn't actually matter. It was good enough in terms of performance, and that all sort of worked out really nicely.
That's cool. And then do you use like because I suppose I'm thinking like, you can use like the AWS SDK that's provided, PHP one and stuff like that to interact with any AWS stuff. Yeah. In this case, we're actually doing something more simple than that. So it's really just sort of using Guzzle to make various requests. But yeah, there's no reason why you couldn't just then start using all the native PHP components and packages that you're used to. Nice. And then what is like kind of your future development with this project? What kind of things would you like to see happening by you or by anyone who is willing to help?
Yeah, so I think that there's 2 trains of thought that I've got at the moment, which is the first one is like keeping it pure to the way that Lambda is kind of designed to be, which is that you shouldn't be trying to like get your whole Express Lambda thing going and having the full Symfony full stack going or anything like that. It really should be something which doesn't even understand that it's HTTP coming in. It's just data in, data out. And so that's the first line there, is that I want to be able to make this sort of a little bit more easy to get going with. So there's some documentation there's some testing that needs sorting out. And I also would like to experiment a little bit with the performance end of things, because as we were talking about earlier, those containers do actually last for a little bit of time. So rather than having to spin up a PHP binary every single request and then kill it off and do the same thing again, I kind of think that, well, why don't I spin up, say, PHP FPM at the start, and then that stays warm as well, which I don't really see why that wouldn't give me some, some performance benefit, at least for the warm starts. I mean, the cold start's probably going to be just as bad, but if I could get that to work, that would be really, really good. So I think that's the big thing on that side of it, is to just try and address that performance. There's also been calls from a few people in the community to make it a little bit more like the Java implementation. So instead of just getting like essentially an array in as your data when you get invoked, it would actually come in as certain object types. So you can actually have interfaces to drive everything, which might make discovery of the data structures a little bit easier.
And testing it, I suppose, and things like that would be a bit more contractual.
Yeah.
Just a little bit performance overhead, though.
Oh, yeah.
By milliseconds, but you're having to generate these classes just for maybe possibly using them.
Yeah. So there's always pros and cons to these things. So it might be that maybe I think the way the Java one works is actually all of those interfaces are kept in a separate repository which you can pull in. So maybe that's the way to solve it. Like if you want it, bring it in, use it as a component. That gives you all that contract if you want it. If you don't want it and you want it to be a little bit quicker, then great, let's not bother. And I think the other side of it is actually thinking about the whole, like, let's get Symfony full stack running and make this feel like a web service rather than just like a function.
It's great for adoption to do something like that.
Yeah, exactly. Because people are going to feel really comfortable in that space. There will be definitely a number of problems that need solving. I mean, the first one that I came across was an issue raised on the project, which just said, "Oh, I've tried to use like the header function, the built-in header PHP function." You're not in a request context. You're just So I think that there's definitely some demand there for that. So it kind of feels like really they're probably two separate projects, and I guess would probably split them apart for that reason. But it would be really cool if you could do like composer install serverless PHP and away it goes, and just sort of brings in all the components and things you need and gets you set up. That'd be really nice. So yeah, I've got quite a few ideas around that. It's about finding the time, and it's about finding hopefully there'll be some other people who are sort of willing to donate a little bit of their time as well and get this thing really off the ground.
Absolutely. No, it's a great idea and it's a great project. And I really, admire you for, getting it off the ground, because it is something that I think we all really, especially if you're looking at serverless, and it's not just you want to bring your language, it's like, oh, I know PHP, so I want to bring it, like it's the fact of, you say, the tooling, the community around it, and the fact that it is actually a viable choice for something like this. Like if you can have Java as a viable choice, PHP is definitely a viable choice for it.
Yeah, absolutely.
I want to say that thank you so much, Andy, for coming on the show. I really appreciate it, and it's been great to chat about all this serverless stuff with you. No,
it's been a real pleasure. Thanks for inviting me.
No problem, man. I'll definitely have to do it again some other time when the project's, more development on the project and whatnot. And when the nice thing about AWS and serverless and all these type of things is it grows every month. There's always new things going on. So I'm sure there's scope for another podcast in here.
Yeah, absolutely.
Brilliant. All right then, audience. Well, it's been another great episode, and I'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.